Have you ever wondered how we know if a new car is safe? Or who's really ahead in a political poll? Well, the answer isn't magic. It's a really powerful tool called statistical sampling. And it's basically the science of using a small piece of something to understand the whole thing. Okay, let's get into it. So, to get our heads around this, let's just start with a real-world problem. How do car companies actually prove that their cars are safe enough for you and me to drive on the road? I mean, how do they test them? Yep, they have to crash them. But you see the problem right away, don't you? To sell cars, they obviously can't crash every single car they make. That would be a very short-lived business model. And this one simple fact gets us right to the heart of why we even need sampling in the first place. And that right there points to a huge challenge. A lot of the time, it's pretty much impossible to study everyone or everything. Trying to get info from every single person or item, what we call a census, it just isn't always the right answer. The reasons are pretty simple when you think about it. First, there's the cost. Can you imagine how much money it would take to contact every single person in a country? Then there's time. A full census can take years to complete. And finally, just like we saw with the cars, sometimes it's just completely impractical because the test itself destroys the thing you're trying to sell. So if we can't look at everything, what do? Well, we take a slice of the whole. The whole idea behind sampling is to use a small, representative piece to understand the big picture. It's a lot like tasting just one spoonful of soup to know if the entire pot is seasoned correctly. Now, to do this right, we've got to get a few key terms down. First up is the population. This is the entire group we're interested in. We're talking about all the cars being made, or all the voters in an election. That's our ultimate target. And then there's the sample. This is a specific, smaller group that we pull from the population to actually study. It's the handful of cars we actually crash test, or the group of voters we call up on the phone. So what's the goal here? What are we actually searching for? That's what we call a parameter. This is the true but unknown number for the whole population that we're trying to figure out, like the true percentage of voters who support a candidate. And this is where it all clicks. We take our sample from the population, we measure it, and then, and this is really the magic of it all, we make an inference. That's just a fancy word for an educated guess about the true parameter for the whole population. But, and this is a huge but, that educated guess is only reliable if we pick our sample in a really careful way. It turns out that how you pick your sample is just as important, if not more important, than how many you pick. Not all methods are created equal, not by a long shot. You can basically break all the methods down into two main families. On one side, you've got probability samples. This is the gold standard. Here, every single person or thing in the population has a known chance of being picked. It's all based on math and probability. Then you have the other side, non-probability samples. These are often the quick and dirty methods based on what's easy or convenient, and they are super prone to introducing bias. You honestly see these non-probability methods everywhere. A convenient sample is just grabbing whoever's around, like those man-on-the-street interviews you see on TV. A purposive sample is when you deliberately handpick people for a very specific reason. And a quota sample is when you try to find, say, 50 men and 50 women to talk to. They can be useful sometimes, but for getting an accurate picture of a whole population, not so great. The gold standard methods, on the other hand, are way more robust. A simple random sample is literally like putting everyone's name into a giant hat and drawing them out. Pure lottery. Systematic sampling is when you pick every 10th person or 100th person off of a list. Stratified sampling is really smart. You divide the population into groups that make sense, like age groups, and then you take a random sample from each of those groups. And cluster sampling is when you randomly pick entire groups, like city blocks, and then interview people within those blocks. Okay, but even when you're trying to use these really good probability methods, things can still go sideways. And this brings us to the #1 villain of this whole story. Bias. Because let me tell you, a huge sample that's biased is so much worse than a small sample that's been designed well. This is a perfect way to see how bias just sneaks in. Think about a phone poll trying to reach likely voters. You start with your target, all voters, but right away, your sample shrinks. Your list only has people with listed phone numbers. Then, boom, it shrinks again, because a bunch of people don't pick up the phone. And then, boom, it shrinks again, because some people just hang up on you. By the end, the small group you're left with could look totally different from the population you wanted to study in the first place. What you're seeing there is a classic case of something called selection bias. It's what happens when your method for choosing your sample just systematically leaves certain types of people out of the picture. That leaky funnel pretty much guarantees that people who don't have phones or who screen their calls just aren't going to be represented. And this kind of bias is hiding everywhere. If you have an incomplete phone list, that's called undercoverage. When people refuse to answer, that creates non-response bias. And what about those online polls where you choose to participate? That's a self-selected sample. And historically, it's one of the most unreliable types out there. If you get this stuff wrong, you can end up with a total disaster, like the infamous 1936 poll that wrongly predicted FDR would lose the presidential election in a landslide because they only sampled from people who owned telephones and cars, who, at the time, were much wealthier than the average voter. But wait, there's another hidden trap. This one's called measurement bias. Now, this isn't about who you ask, it's about how you ask. It's when the questions themselves or the way they're asked actually push people toward a certain answer. This can be caused by something as simple as a leading question. Like, don't you agree that this new policy is a fantastic idea? That wording is obviously pushing you. It can also be the interviewer's own influence, or even just a person's desire to give an answer that they think makes them sound good instead of what they actually believe.
So, with all these potential problems, how do we judge whether a sample is any good? Well, it's absolutely crucial to know the difference between two types of error. One is just an unavoidable part of the process, and the other is a preventable mistake.
First, you have sampling error. Look, this is natural. It's unavoidable. You just have to accept it. It's the simple reality that a sample is never going to be a perfect 100% mirror of the population. There's always going to be some random difference. This is what you hear about as the margin of error in polls. We can make it smaller by getting a bigger sample, but it'll never be zero. And then there's non-sampling error. Now, this is the bad stuff. This is a flaw in the design of the study itself. It includes all the biases we've been talking about. And here is the single most important thing to get. Making your sample bigger will not fix this. If your method is flawed, a bigger sample just means you're more confident in the wrong answer.
Which brings us to what is, without a doubt, the biggest takeaway from all of this. If you remember one thing, please make it this. The design of the survey is far more important than the absolute size of the sample. I'm telling you, a well-designed, unbiased sample of 1,000 people will beat a badly designed, biased sample of 1,000,000 people every single time.
So I'll leave you with this challenge. The next time you see a headline with a poll number, don't just ask how many people they talked to. Ask yourself, how were those people chosen? Now that you know all this, what's the first thing you're going to question?